Okay, well this is a 2N3055 transistor. You can see there's lots of little bits attached to it at the minute, and I'm just going to show you it at this angle so you can see that the two poles are not directly in the center of these, and at the minute I've got them closest to me, and that's important because that's how you tell the difference between the emitter, the base and the collector. And so, which is which? Right, well, with the poles closest to you, that pole, the one on the left, is the emitter, the one on the right is the base, and the actual body of the transistor, so all this metal bit, is the collector. So that's what confused me when I first started, so I thought I'd just point that out. And now I'm just in the middle of turning this into another Bedini circuit, so I wish you could see this, but it's all blurred. I have a diode, 1N4001, and that's going across from the emitter to the base, so the stripe is closest to the base side. And then on the right hand pole as well, which is the base, I have a resistor, and at the minute this is a 430 ohm resistor, and that'll be going to my potentiometer, also known as a pot. And then connected to the casing of the transistor is my other diode, which is a 1N4007, and that's connected to the collector, and that'll be going to the charging battery's positive. There we go, one fully soldered Bedini circuit. It's a real shame this video is so blurry, but so you get the idea where everything's positioned. This 430 ohm resistor is now going to this potentiometer, and you can twist the top there, and that changes the resistance of the trigger. So there you go. Just got to build the second coil and hook all the wires up.
Okay, so onto the coils. Like I said, it's got two wires wrapped around the same core, so it's basically a bifilar coil. One wire is a 22 gauge wire, and the other wire would be a 26 gauge wire. The gauge basically relates to the thickness of the wire. So the lower the gauge, the thicker the wire. So the 22 gauge wire is going to be the thicker one, which we're going to use for the power coil, and the thin wire, the 26 gauge wire, is going to be the trigger coil. So yeah, why do we use the two different size wires? Well, there's a good reason. The 22 gauge wire we use for the power coil because it's thicker, and thus there's going to be less resistance in the circuit when it makes the magnetic field. And then we use the thinner coil for the trigger wire because we don't have to worry so much about the resistance, but we could use a thicker wire for the trigger coil as well, but we don't need to, and it would just make the coil bigger. Say if we were to look at a cross section of the electromagnet. So as you can see, the 22 gauge and the 26 gauge wire fit very snugly together. But then if we look at what it would be like when we use two of the same gauge wire, you can see we can't fit nearly as many turns on the same core. So the wires are much more compact, so we can get a much stronger electromagnet using the 22 and a 26 gauge wire than say if we were using two 22 gauge wires. So these two wires are wrapped in parallel around the core, and you want to use at least 650 turns around the core of both the wires, so you're going to wrap them together at the same time. I'm using closer to 1,000 turns on the coil, but the more the merrier. And some people have managed to get this to work using an air core, but I think that will only work if you're using very strong magnets, which we don't want to use. We want to use fairly weak ceramic magnets. So you're going to need to use some kind of metal core. Lots of things you could use. You could use just a regular steel bolt, put that down the middle of the coil. Or, as Bedini recommends, you could use welding rods, just cut to the right length, and then just whack as many as you can into the center of the coil, and then stick them all together with super glue. Now this is better than using just a single lump of metal, because it creates less magnetic flux in the coil, so the magnetic field can switch much more quickly, and this helps the effect of charging the batteries. Now you could use a few other things if you can't use welding rods. Say I can't get welding rods, so what I'm using is magnetic sand, or you could even use just regular iron filings. Mix that with a bit of glue, a fair bit of glue, so you have basically consistency of cement. Shove all that mixture into the core, and just let it set, and then you basically got yourself an iron core made of lots of tiny little bits of iron, and that really reduces magnetic flux. And yeah, that's possibly one of the best coils you could use in my experience anyway, but I haven't tried the welding rods, so not too sure about that. Maybe somebody can shed some light on that if they've ever compared them.
Right, now let's start putting this together. So here we have the first diagram I showed you. So we've got the transistor, the two diodes, a resistor, and the potentiometer all hooked up already. Then we have to hook up 5 wires, look a bit like that. So we've got 2 wires connected to the emitter, 1 wire connected to the collector, a wire on the diode coming from the collector, and a wire coming from the other end of the potentiometer. And then what we're going to do is we're going to number these wires just to make it nice and simple. So we've got 1, 2, 3, 4, and 5. So it looks a bit like that. And okay, so now we've got that sorted, we move on to the coil. There we go. So here's the coil, and now you probably have 2 wires coming out the top of the coil and 2 wires coming out the bottom of the coil. The red wires in this diagram are the power coils wires, and the blue wires are the trigger coils wires. Okay, so now we're going to number these as well. So we've got 3, 2, 4, and 6. Look a bit like that. And then, something I haven't shown you yet, we've got the batteries. And this doesn't look very logical, but this is how we're going to wire the batteries up. Self-explanatory really. The battery marked with the S is the secondary battery, which will be charging, and the battery marked with a P is the primary battery. And now you can see we've got 3 loose cables coming off of here, and we're going to number those as well. So we've got 1, 5, and 6. So let's put it all together. Here we go. So now these are the 3 parts that you build separately, and then to hook all those wires together, let's have a look at how these loose cables are numbered. There you go. Now that looks really complicated with loads of numbers everywhere, but I'm going to upload all these images onto another page somewhere on the internet, and I'll post links in the description section so you'll have access to all of these. But really it's very simple. The wires that are numbered the same are going to be connected together. So for example, the wire on the transistor that's marked 2 will be connecting to the bottom of the core, which is also marked 2, and that's a blue wire there for the trigger wire, for example. So all those are going to connect together. So let's see how they all connect together on the schematic. So that's the basic Bedini schematic, and there you go. Those are the connections. And now I'll make a nice compact circuit without too many loose wires going all over the place, and yeah, that's pretty much it. Now there's one part of the schematic that I haven't actually mentioned yet, just for simplicity, because it's not absolutely essential for the motor to work, but it's more of a safety feature, and that is one of these, which is a neon bulb. Now the neon bulb, like I say, it's a safety feature. Really it acts in a way like a spark gap. It only turns on when it's got about 90 volts going through it. So most of the time it's going to be off, but with the Bedini motor it's letting out very high voltage pulses. That could fry your transistors, and you're going to end up having to build it all over again basically. Like I've gone through about maybe 20 of these transistors. It's ridiculous, even with the neon, because I short circuit it. But without the neon I'm going to short circuit it even more, so the neon, essential, has to be in the circuit. So let's hook that up as well. So very simple, very simple, very simple. This is the first diagram I showed you before. So all we have to do is hook up the neon, one end of the neon, to the emitter, and one end to the collector. So it would look a bit like that. Very simple. So those are the basics when learning how to build a Bedini motor. You now know how to wire the circuits, and to hook up the batteries you know pretty much all you need to know. There's still plenty more information online about how to build the rotor and the construction of the motor itself.
And I will be making more videos soon about the motor, like how to test it and how to find out how much power you're getting out of it and how to improve it and how to hook up more coils. So yeah, still lots to talk about, but you now know how to build one, so go do it. Build it.